Well, what do open, closed, or filtered actually mean? Let's take a closer look at the results of Nmap. When Nmap sends packets to a port and receives a positive response, the port is assigned the state of open. For example, SynScan receives a SYNAC from the destination system if the port is open. If Nmap determines that a port is not available, it assigns it the closed state. This signifies that Nmap has received a result that clearly shows that the port is closed. A SynScan receiving a RIST in response to a port query is an example of a closed port. Filtered ports are the result of a packet filter or firewall when no response at all is received from the remote device. The port is considered to be filtered. Since a response isn't received from the port, Nmap often retries communication to the port to ensure that the packet wasn't simply dropped due to error or congestion. Please note that this type of response is categorized differently if this is a different scan type, such as a UDP scan or a fin scan. The next result, open filtered, is coming in a minute. On the other hand, if the destination systems return an unexpected response, again the port is considered to be filtered. If we get an ICMP unreachable response in a SynScan, the port is flagged as filtered. Now, in some cases, the lack of a response may not necessarily mean that a port is filtered. Lack of a response might mean that the port might also be open. Now, in these situations, Nmap signifies that the port is either filtered or open. For example, in a UDP connection, in most cases, the destination system does not send a response when it receives a UDP packet. So if the destination system does not respond, Nmap categorizes it as open filtered. Make sense? In this slide, you see some of the most known default ports. So here's the question. If the port 22 is open, is the service running there absolutely in SSH? Could there be another service? Well, these are the default port numbers of the services. You can run any service in any port. You can run HTTP on port 22, for example. But for the ease of use, the default ports are used in general. So if you're performing a pen test, you should probably look at the well-known ports first, but you should never just scan the default ports. There are different ways to scan ports with Nmap. Let's see how we can scan ports. Let's prepare a SynScan for a Metasploitable device. The IP address of my Metasploitable is 172.16.99.206. If you do not use any one of the port scanning parameters, top 1,000 ports are scanned. Top ports are the most used ports in general. The first way of choosing the ports to scan is using p-parameter. After entering the scan type and target IP, enter the port numbers with p-parameter. You can enter ports one by one, separated by a comma, or you can give a range of ports by putting a dash between the port numbers. In this example, the ports 22, 80, and the ports between 100 and 200 are scanned. If you perform both TCP scan and UDP scan in a single Nmap query, you can choose both the UDP ports and the TCP ports using p-parameter. For this Nmap scan, we'll use both SynScan and UDP scan at the same time. We haven't seen it yet, but the UDP scan is performed using S capital U parameter. And as you know, the SynScan is a type of TCP scan. After entering the target IP, put -p. To enter TCP ports, put uppercase T with a colon just after the parameter P and the TCP ports to scan. Same as giving port numbers directly with p-parameter. You can enter ports one by one, separated by a comma, or you can give a range of ports by putting a dash between the port numbers. To specify the UDP ports, put U, that's an uppercase U, with a colon and the ports with the same format. For this example, let's scan the TCP ports 22 and 80, and the UDP ports 53, and the ports between 139 and 150. So here are the results, TCP ports first and then UDP ports. Another way to specify the ports is using top ports parameter. Using this with the number of ports that will be scanned, you can scan the top ports within this parameter. So let's scan top 20 ports for this example. So here are the top results of the most used 20 ports. If you use uppercase F, which means fast scan, top 100 ports are scanned. So let's perform an Nmap SYN scan with F parameter here. And open another terminal screen and perform another Nmap scan using top ports 100 parameter. As you see, we get the same result because these are the same queries. If you'd like to scan all the ports of the system, well, you should scan all the ports of the systems in a pen test. You have to use the P parameter with the interval from 1 to 65535. This is the range of possible port numbers. Prepare the Nmap SYN scan query with the destination IP address. Now put P1-65535 and hit Enter. Here are all the open ports of Metasploitable. By default, Nmap does host discovery and then performs a port scan against each host it determines is online. If you use pn in the Nmap query, you skip host discovery and port scan all target hosts. Disabling host discovery with pn causes Nmap to attempt the requested scanning functions against every target IP address specified. So if a Class C target address space, that means 24 is specified on the command line, all 255 IP addresses are scanned. Now, why would we want to do this? As you know, if you are a privileged user, Nmap sends 4 types of packets to discover hosts: ICMP echo request, SYN packet to TCP 443 port, ACK packet to TCP 80 port, and ICMP timestamp request. If a system is configured not to answer to ICMP requests, and if the ports 80 and 443 are filtered, then Nmap thinks that the host is down even if it's up. If you find a system which is not found by ping scan, always use pn for further port scans. Otherwise, Nmap doesn't perform the port scan because it assumes that the host is not up. So if your network is not big, or if you don't have enough time to scan, you should skip the ping scan and run the port scans for every possible IP address. Use the port scan instead of ping scan if you are scanning a server block, because those systems are configured to be more secure than usual. Then you can find more computers than the ping scans do. You're halfway there.